Hello, I'm Karen Johnston from the Department of Chemical and Process Engineering at the University of Strathclyde, and I'm going to tell you about a project I'm running on sustainable plastics. This is one of 10 funded projects on smart sustainable plastic packaging across the UK. There are two main issues with plastic packaging. The first is that most plastics are sourced from petrochemicals. The second is that there are major issues with plastic pollution, which damages wildlife and the natural environment. So ideally, we want to reduce our plastic use, reuse where possible, and recycle. However, plastics such as these ones are really useful for keeping food fresh, and this avoids food waste, which is a major contributor to greenhouse gases. But however, these are not recyclable because there's food contamination. So what we want to do is develop sustainably sourced plastics that are compostable, so they can go out with your food waste or into your home composting. So currently available sustainable and compostable plastics are not yet good enough for food packaging, so our research aims to improve the currently available plastics that are available and use those for food packaging materials.
Hello, my name is Kasia and I work with Karen on the optimization of biocomposites for food packaging on the experimental side of the project. When you're shopping in the supermarket, you probably don't register anymore how many products require various types of packaging. Among these, food packaging prolongs freshness of the product but leads to contamination of the environment as they are not recyclable. Most of the polymers used for packaging exist in a powder form that is further changed into polymer film after applying heat. This process already requires a lot of energy, so we are trying to minimize energy usage in the next steps of the process. So what are the properties that our new packaging material should have? It should be resistant to air and moisture to prolong shelf life of the product, but also be biodegradable and with good mechanical properties. For our research, we have chosen polyhydroxybutyrate as this polymer is produced by microorganisms, is biodegradable, and its properties can be tuned by introducing additives into the system. What do these additives do? Imagine a bowl of spaghetti with a random way of noodles entangled together. This is how amorphous polymer can be imagined. Crystalline polymer has a long-range order and therefore is much stronger but also brittle. Usually, polymers are semi-crystalline, a mix of these two states. By introducing the additives into the system, we change the amount of small polymer crystals and therefore mechanical properties. Our project will investigate how environmentally friendly additives influence this process. We will do this by collaboration between experimentalists and computational researchers. My group will investigate materials in the lab, preparing them in small scale using press presented in the picture. This data will be used by Karen's group to model the behavior of the film in the broader context and predict their behavior, creating a set of advices for industrial partners. So next time you're in the supermarket, just look around and see how much plastic is everywhere and why this problem is so important. Thank you!